Assalamualaikum and salam sejahtera to all my students. Okay, for our lesson today, okay, we will learn a new chapter, chapter 13, a simple probability. Okay, so for this chapter, we will learn four subtopic. First one, 13.1, it is a experimental probability. 13.2, probability theory involving equally likely outcome. 13.3, probability of the complement of an event. And 13.4, a simple probability. Okay, all right, class. Okay, so now please look at this statement. A pink team and a blue team are playing against each other in a netball game. Based on the record, the pink team scored 12 goals out of 18 attempts. Okay, the blue team scored 18 goals out of 30 attempts. Okay, what is the ratio of the goal to the attempts for the pink team and the blue team? All right. So in your opinion, which team will win the game? Okay, so for this one, all right. Okay, we will know the team which is have a huge opportunity to win the game based on the ratio given. Okay, if you find the ratio of the goal score by the pink team, okay, which is 12 over 18, okay, and then if you find the ratio for the goals score by the blue team, which is 18 divide with the 30, okay, you will find that the the ratio get by the pink team is higher compared to the ratio get with the blue team. So the higher the ratio getting by the team, okay, the higher chances for that team to win the game. So that's why for this kind of situation, okay, in my opinion, the pink team will win the game because have the higher ratio of the score the goal of the attempt. Okay, all right. Okay, now look at the first subtopic there. All right. Okay, but before that, okay, look at this one. The definition for the probability. Okay, probability is the measurement of possible occurrence of an event expressed either in the form of fraction or percentage. Okay, so look at the first subtopic, 13.1, experimental probability. Okay, in the creative activity, you are introduced to the probability concept. Okay, now let's look at the relationship between frequency and the number of trial. Okay, all right. Okay, so this one, uh, this one actually is the experimental probability. You can do this one, all right. How to do this one? Okay, you need to use a coin. So if a coin, there is a two possible you get after you flip the coin, which is either you will get the head or tail. Okay, so this one you can do at home. All right, you can flip the coin 25 times. Okay, then after that you record the number the number of flip. Okay, after the first, okay, the number of flip for the 25 flip. So how many head occur and how many tail occur, and same with this one after 50 flip, how many head and tail occur. Okay, you can do and you can complete this one by your own self. Okay, this one we can call as the experimental probability. Okay, so the relationship between the ratio obtained and the experimental probability, okay, you will know if you use the formula here, which is a ratio equal to the frequency of appearance you divide with the number of lead. Okay, let's say for the first one, let's say the ratio, okay, for the 25 number of lead, okay, so head, let's say you get 10, so 10 you divide with the 25, okay, so that is the ratio. If the head you get 10 for the number of lead 25. Okay, that's how to calculate the ratio. Okay, next. Okay, experimental probability is the probability that is obtained from an experiment. Okay, ratio, frequency of appearance towards number of lead that is obtained from flipping the coin is the experimental probability for an event. So in general, the formula, this one, the experimental probability of an event is equal to the frequency of an event divided with the number of trial. Okay. Okay, now look at this one. Okay, all right, this one. We go for this one, 13.2. The probability theory involving equally likely outcome. Okay, 13.2.1, sample space for an experiment. Okay, so how to know the sample space? What is the sample space? Okay, before starting a football game, the referee usually flip the coin to decide the team that will start the game. Why does the referee use a coin and not dice or others object? Okay, what is the sample space? Okay, what is the sample space of the possible outcome of flipping a coin? So class, if we flipping the coin, so there is two possible that we will get, whether we will get the head or tail for that coin. That means there is two possible outcome. First is head, the second one is tail. Okay, all right. So look at this one. A coin has only two faces. That is the head and tail. Okay, what is the sample space for the one flip of the coin? So the sample space for the one flip of the coin, it is a head and tail. Okay, that is the sample space. Sample space is the all the possible outcome from the experiment. That what we call as a sample space. And for this subtopic, you also need to remember about the set, which is you already learned in the form 1. Okay, the notation for set. Okay, this one, the notation for set. And let's say set A equal to this one, the notation for set. Okay, odd number less than 10. So set A, you can write like this. It is equal to, okay, notation of set. So this one, the number less than 10, it is number 1, 3, 5, 7, 9. Okay, this number we call as the element for the set A. Okay, so this one actually you already learned in the form 1. So please remember this one because we are going to use this one in this chapter. Okay, all right. Okay, next. Okay, okay, this one. When a fair dice is thrown, the number that is shown is either 1, 2, 3, 4, 5, 6. Okay, although the number shown is repeated, it is still in the range of 1 to 6 because for the fair dice, that is only we have only 6 surface. Each surface has number 1, 2, 3, 4, 5, 6. Okay, the outcome list for the thrown fair dice consists number 1, 2, 3, 4, 5, 6. So the sample space for the thrown fair dice is, okay, so we use capital S for the symbol for the sample space. So it is equal to, okay, right, in the form of notation of set like this. So it is either 1, 2, 3, 4, 5, 6. This one is the all the possible outcome. If you uh, if you what if you throw a if you throw a fair dice, so this one is all the possible outcome. All the possible outcome is the element for the sample space. So for the sample space, you have to write like this. Okay, all right. Okay, next. Okay, all right. This one, a tree diagram can help you determine possibility. Okay, sorry. A tree diagram can help you determine probability. Okay, probability. Okay, so look at this one. This one we call as the tree diagram. So we have a box A and also box B. So inside a box A, there is a one card, number 2. Then inside box B, we have 3 cards. Okay, the card number 3, card number 5, card number 7. Okay, when you pick a card randomly, you might get a pair like the one shown in the tree diagram above. Okay, so this one, the possible after you pick randomly in the box A and also box B. So this one you will get, you can write like this in bracket, card 2, comma, card 3. And for this one, okay, you can write, okay, card 2, comma, card 5. And this one, okay, if you pick randomly from the box A and also box B, you will get this one, card 2 and also card 7. Okay, so uh, this one actually is a pair number obtained. Okay, okay, pair number obtained. So the possible outcome of the activity is known as the sample space. Okay, so capital S, it is a sample space for this one. All right, so you have to write in the notation of set like this, and in the notation of in the set there, you have to write all the possible outcome. So that's why inside there you write in bracket 2, comma 3, comma in bracket 2, comma 5, comma in bracket 2, comma 7. Okay, this one is the sample space, which is all the possible outcome from this tree diagram. Okay, so the sample space is a set of all possible outcome of an experiment. Okay, all right. Okay, next. Okay, all right, class. So the next one is the event of an experiment. Okay, okay, event is a set of possible outcomes that fulfills certain conditions for a sample space and is a subset for the sample space. Okay, all right. So please remember this one, what you already learned during Form 1. Okay, let's say we have set A equal to, okay, the element for the set A, 1, 3, 5, 7, 9. Then we have set B. Okay, the element for the set B, 2, 4, 6, 8. And the number of element, okay, for set A, so the number of the element you can write like this, use a smaller n for the number of element. In bracket capital A is the set A, it is equal to 5. Why 5? You just calculate the number element inside set A here, 1, 2, 3, 4, 5. So that's why 5. So the number of element for the set B, it is equal to 4, because here 1, 2, 3, 4. Okay, all right. Okay, now look at this one, the example 1 here. One letter is randomly chosen from the word sempurna. List the possible outcome and write the sample space for the experiment. State the number of elements in the sample space. Okay, so to do this one, all right. Okay, the word sempurna is made up of 8 different letters. If you calculate the number of letters from the word sempurna, 1, 2, 3, 4, 5, 6, 7, 8. There is 8 different letters. So the possible outcome are letter S, E, M, P, U, R, and A. So the sample space, use capital S for the sample space, okay, equal to, okay, use a set notation, and in this set notation there, you have to write all the possible outcome. So, all right, letter S, E, M, P, U, R, and A. Okay, so this one is the sample space for the example 1. And the number of element in the sample space, it is equal to, use the symbol smaller n for the number of element in bracket capital S for the sample space equal to 8. Okay, if you calculate the number of element inside the sample space here, 1, 2, 3, 4, 5, 6, 7, 8. So that's why 8 here. Okay, all right, class. So for our lesson today, I will stop here until example 1. All right, so for your homework, today, please do this one. Okay, I want you to answer self-practice 13.2. Okay, self-practice 13.2. Okay. Sorry, not 13.2. 13.1. Where is 13.1? Okay, all right. So your exercise today, I want you to answer question self-practice 13.1. Okay, please answer question number 1. Okay, just one question only for exercise today. So please do this one in your math exercise. You can use with the math exercise 1, 2, or 3. And if you have any question about the lesson today and also also about this exercise, you can ask me in the Telegram. Okay, so that's all for our class today. Thank you.